welcome back to Higher Change. We are on the fourth chapter, Thinking Like a Scientist. And I'm with my wife here, Hannah.
Hi.
And I just want to ask her some questions about asking questions. So we met and I forgot to introduce my son, but he's off the screen. Anyway, we met in a science class at Andrews University. And can you just tell us a little about how you think that us asking questions played a role in us getting together?
Well, we met in Cosmos class, and the first thing Tom said when he came into class was he asked the teacher a question. And he mentioned that he was studying religion, and I was too. So that kind of created a point of conversation between us. And after that, we would walk to our next class together, and we both come from very different backgrounds. So we had a lot of questions to ask each other about who we were, what we're like, what makes us tick. So that was a long process of discovery, and we're still discovering today.
So the stars literally brought us together. We were in astronomy class. And as Hannah said, I just didn't know if I was going to survive. And so I asked the teacher a question. And then you introduced yourself to me after that, right?
Right, yeah. We had the same major, and also it's cool to meet someone in your major in a different general ed class.
And then we went into knowing that if we hadn't asked each other questions, right? So, in the last chapter, we talked about the importance of listening. But, listening is not enough. We also have to take initiative and ask questions. Otherwise, we wouldn't have the opportunity to get to know each other, right? Right. So you mentioned that we asked each other a lot of questions to get to really know each other, right?
And there's no really other way to get to know each other other than asking lots and lots of questions.
Yeah. So that's the beauty of science too. It's not just that it listens, but it also asks questions of the world around us, and it helps us to understand people, helps us to understand the world. And but it takes a humble attitude. Have you ever been with people that didn't ask questions?
Yeah, so after a while, the relationship kind of seems one-sided if you're the one asking questions and the other person doesn't.
Yeah, I mean, we've probably both been on dates with people where they're just like they're just quiet and they're just not interested in asking questions. It just shows that they're not interested in you, and that's not cool. In the world, we all need it. If we really want to value people, we have to take the time to really ask questions, and that's what science teaches us to do. Otherwise, if we didn't ask questions, then we would be arrogant and think we have to know it all. But in order to get to the point where we ask questions, it has to start with an understanding of our ignorance and the limitations of our knowledge. Science essentially starts with the recognition that we don't know everything. And in order to get to know people, in order to get to know the world around us, it starts with understanding that ignorance and the limits of our knowledge. That leads us to ask questions so we can get to know the world and the people around us. And so that's the point of this lesson today. We're going to look at methods of how we go about asking questions, whether it's quantitative or qualitative, but it all comes down to that. Thinking like a scientist and the importance of asking questions. The main point of this lesson is while it is attempting to trust in the expertise of others or to be confident in our own education, wisdom starts with an understanding of our ignorance, looking for gaps in our understanding and knowledge, and the ability to ask questions and stay open-minded is an important skill for critical thinking and discernment. Science also demands observable evidence to make propositions about what is true. Psychology, as a form of science, uses scientific methods to gain an understanding of human behavior and mental processes. Social sciences tend to use inductive methods. However, because we often do not know what we're missing, psychological science progresses in stages. As our biases can make objectivity difficult, some believe that truth is more subjective and relational than propositional. So in this lesson, you'll differentiate methods of acquiring knowledge, including authority, reason, and observation, and their pros and cons. You'll describe the importance of asking critical questions. You'll list the basic steps of the scientific method. You'll differentiate the types of psychological research and the pros and cons of each. And you'll list the steps of design and experiment. And lastly, you'll identify basic principles of ethical research. Let's start by talking about wisdom and asking questions. The ancient Greeks believed in the importance of wisdom, which in Greek is Sophia. This word meant being intelligent, wise, having good judgment, and being discerning. Here's a picture of
the Academy of philosophers, Greek philosophers. The word philosophy literally means the love of wisdom. So Sophia is wisdom, philo meaning love. So the love of wisdom. Why is philosophy important to psychology? This is a class on psychology. Well, Greek philosophers helped lay the groundwork for Western science, so it's important to understand the nature of science. Socrates, who lived in 469 to 399 BC, was considered the founder of Western philosophy, though most of what we know of him comes from his student Plato. The Oracle of Delphi told his friend that he was the wisest man, but he did not think so. So Socrates went around trying to find wise men, or sophists. The sophists were intellectuals who held themselves out as authorities or experts or authorities in specific subjects and charged high prices for their teaching. So we can imagine him running around talking to people. And what Socrates found were people who spoke eloquently and thought they were wise, but who actually knew very little. Thus, he and Plato considered them to be frauds and not real philosophers who sincerely love wisdom and seek the truth. And in contrast, Socrates was aware that, quote, I know that I know nothing. And if he did know something, he felt it was worthless. And he deduced that wise people admitted their ignorance. And this was called Socratic ignorance. The whole Western scientific traditions start in the foundation of recognizing our ignorance. Socrates is known for his Socratic method, a method of posing questions and answering them. Western scientific traditions require that we must be critically skeptical and open-minded. In fact, the scientific method starts with asking a question, which requires knowing the limits of our knowledge. So that takes us to look at what are the sources of truth. We gain our knowledge of the world around us through different ways, and there are three main sources of truth. The first one is authority. We humans look to other trustworthy, credible people for our knowledge. These include parents, school teachers, scientists, medical professionals, and religious teachers. Schools and churches often are responsible for transmitting knowledge from one generation to the next throughout history. And they teach us what we know when we're children, because otherwise, you can't go out and do a scientific research study every time you want to learn something. Sometimes you just look things up, or we ask somebody. The next thing is observation. We can simply make new observations through our senses about what we know to be true. And as we will see, empiricism is tied to deriving knowledge through observation and senses. And the third thing is reason. We can use principles of logic to come to certain conclusions. So first of all, some terms you should know. Empiricism is tied to deriving knowledge through observation and senses. That's the second category. And then there's rationalism. Rationalism is the theory that reason, rather than our senses, should be the foundation of knowledge. And thanks to Socrates, science is naturally skeptical of authority as a means of knowledge. That's because authority can be wrong sometimes. So while it can be helpful, we maintain skepticism about it. And one of the oldest debates in science is whether new knowledge is attained through our sensory experience or through our reasoning. So let's look at the next category, which is rationalism. Socrates' student Plato, who lived in 420s to 340s BC, believed that our senses can deceive us. He believed that we should compare it to what we already know innately. He was a nativist, so he would not believe in sensory experience because senses can deceive us. And following after him, his student Aristotle. Aristotle was a student of Plato and who famously tutored Alexander the Great. And while Aristotle believed in the role of sensory experience, he believed that knowledge was gained through both senses and reason. So thus he expanded on the role of reasoning and founded a system of logic, particularly deductive reasoning. So these people were very big promoters of rational thought, reasoning and rationalism. And more toward modern times, Rene Descartes, who lived in the 1596 to 1650, was a medieval French philosopher and scientist who revived interest in rational thinking. And while he believed in a dualistic mind-body distinction, he believed that our ability to think and reason apart from our senses, including to believe in a God outside of our sensory experiences, was innate. And he said, he's famous for saying, "I think, therefore I am." So we saw the importance of rationalism, which brings us to the subject of critical thinking and logical reasoning, which is the outgrowth of that. Critical thinking is the ability to analyze facts to make reasoned judgments. It derives from the Greek word critic and implies an intellectual capacity to critique, judge, or discern. This kind of thinking dates back to Socrates taking a not knowing stance of curiosity, recognizing the limits of knowledge, and his method of asking probing questions. In critical thinking, claims by authorities or experts are not necessarily true, as everything should be tested. And there are several basic kinds of logical reasoning that follows rules. So there are two different kinds, and the first one is deductive reasoning. Deductive reasoning starts with several known facts or premises and draws conclusions by combining the facts. In social science, this is often done in creating a hypothesis based on the research literature. Inductive reasoning, in contrast, starts with a series of observations and draws an inference or conclusion based on the repetition of the observation. In social science research, conclusions are usually drawn after collecting enough data. However, there's a limit to this, as one may never know if there is an exception. You may gather hundreds or thousands of data, but you may never know if there is one exception to all that. And that's been a problem. So as we saw, deductive reasoning starts with several known facts or premises and draws conclusions by combining the facts. And social science is often done in creating a hypothesis based on the research literature. Inductive reasoning starts with a series of observations and draws an inference or conclusion based on the repetition. In critical thinking, because not everyone fits into a theory, social science tends to rely more on inductive reasoning. Yet most social science research involves both inductive and deductive research. When a researcher wants to study dating relationships, they will first look at the existing research and create a hypothesis about dating using deductive reasoning. Then they'll either conduct surveys or interviews of couples until they're able to establish patterns, creating a theory about relationships. This is inductive reasoning. So let's talk about empiricism. We talked about rationalism. Let's talk about empiricism. Aristotle deviated from Socrates and Plato in that he believed that all knowledge in the mind first came through our senses or through our sensory experience. The word empirical comes from the Greek word for experience, empira. That's why it's called empirical. Empiricism says we must have evidence to believe something and is the foundation for empirical research. It tends to rely on inductive reasoning using observations as evidence. This approach has been in conflict with religions that put emphasis on faith and tradition. For example, empiricism seems to be challenged by stories in the Bible where Jesus Christ healed people and raised someone from the dead, and reportedly said, "Happy are those who have not seen and yet believe." So faith is seems to go against that, especially Hebrews 11 says, faith is the evidence of things that are not seen. So empiricism is all about, believing only in what we can see through our senses. Unfortunately, Christian dogma and tradition have repressed scientific progress throughout the Dark Ages because of this seeming tension. So here's a picture of Galileo, who went before the Catholic Church Inquisition. So Galilei lived from 1564 to 1642. He was an astronomer who is considered to be the father of modern science and the scientific method. He sought to divorce science from religious tradition. Tradition would come under the domain of authority as a source of truth. Not that it isn't an important source, but that science needs to be different from that. So because he taught Copernicus's heliocentric theory that the sun, not the earth, was the center of the universe, which seemed to go against church teachings. It did. He was tried by the Roman Inquisition for heresy and held under house arrest for the rest of his life. Eventually, religious wars led to the Roman Catholic Church losing its grip on governments. People advocated for a separation of church and state to avoid further religious conflict and to let people to live in peace with each other. After religious liberty increased, people felt the freedom to reject religious tradition and dogma, and this led to the flourishing scientific revolution. Here's a depiction of Isaac Newton, who was one of the important figures in the scientific revolution. So let's talk about the nature of modern science. Today, modern science combines the emphasis on critical thinking or reasoning with empiricism, the need for empirical evidence. Therefore, science is a practice of making empirical observations about things in the universe and organizes these observations as knowledge that can explain and make predictions. Much of the history of Western science is about establishing paradigms that explain empirical observations. The limitation with this is that we never know when something does not match our observations simply because we have not seen any exceptions yet. As we've seen in the history of psychology, science can sometimes be wrong. In Thomas Kuhn's classic book, The Structure of Scientific Revolutions, he posits that science does not progress through gradual improvements, but through radical paradigm shifts. Anomalies are incidences or data that are inconsistent with our old paradigms. When we discover anomalies, they force us to find and adopt new paradigms that explain them. New paradigms then force us to ask new questions of our old data, which may change the way we structure our knowledge and change the direction of our research. So psychology is a natural science. The definition of psychology is a scientific study of behavior and mental processes. That's different from neurology, for example, which is basically the study of the organic side of the brain. Psychology is a study of behavior, which is the outgrowth of the brain or the product of the brain, and the mental processes, the thought processes. It is a hub science in that it's connected to many different fields. The four goals of psychology are to describe, explain, predict, and control. So it describes what is happening, explains why is it happening, it predicts when will it happen again, and controls how it can be changed. It's interested in how we control the behaviors and mental processes of both humans and animals. We want to know how to influence people because people have a need to, such as through marketing and advertising, leadership, and that sort of thing. There are two kinds of research that psychologists engage in. Essentially, there's basic research, which adds knowledge to scientific knowledge, so adds information. And then there's practical research that finds practical solutions to actual problems. So psychology, like any science, takes a scientific approach to discovering new truths. The scientific method is a system of gathering data so that bias and error in measurement are reduced, and that's called the scientific method. Like all scientists, psychologists use this method to help ensure replication, falsifiability, transparency, and reliability, etc. What's the difference between a hypothesis and a theory? Both of them are important to the scientific method. The hypothesis is a tentative explanation of a phenomenon based on observations. The hypothesis is usually intended to be tested with a follow-up study or a study. So you usually start a study with a hypothesis. The general scientific explanation of a set of observations or data gathered so far is called a theory, and these are usually published and peer-reviewed to get confirmation or critical feedback of others. So you can see that all these things work together. You start with a hypothesis or premise, which you use deductive reasoning to look for, you establish that, and then you go out and look for these empirical observations, and then based on those empirical observations, you use inductive reasoning to draw another theory, okay? But the theory, this is just how the deductive and inductive reasoning process work together. What are the 5 steps in the scientific approach? First of all, we start with perceiving the question, usually based on holes or gaps in existing research. The second thing is we formulate a hypothesis. And that means we try to figure out what is the thing that we're testing. Well, we know what we're testing, but we want to know what is the thing we want to argue. What is the thing we're trying to prove? And so usually a hypothesis says what we expect to find or not to find. Testing the hypothesis we test this hypothesis using a structured method. That way we can rule out any other confounding influences that could make our conclusions wrong. We want to reduce the potential for errors. And the fourth thing is we draw conclusions, and lastly we report on our results. And actually this method is usually, if you look up any research paper that's published, you usually find it following this formula. So as I was saying, that there's theory, hypothesis, research, and observation. All these things work together in a cycle. So we start with a theory, previous theories, then we draw a hypothesis for future research, then we conduct a research, we draw observations, and based on those observations, we establish or we refine theory. And then based on those established theories, we draw new hypotheses for future research. In the social sciences, there are typically 3 categories of scientific methods employed. There's the descriptive, correlational, and experimental methods. So we'll take a look at each of these. First is the descriptive methods. There are 2 important approaches or goals in descriptive psychological research. First, the nomothetic approach comes from the Greek word nomos, meaning law. Psychologists who adopt this approach study what we share with others to establish laws or generalizations. The idiographic approach comes from the Greek word idios, which means own or private. It focuses on uniqueness and variations from the norm, as is seen in abnormal psychology. And this is all according to Wilhelm Windelband, who came up with these terms. And then there are also 2 categories of descriptive methods used. We can look at it in another way. There's the quantitative methods. Quantitative methods focus on quantifying data in order to create generalizations. So quantity is about numbers and counting. So they may use surveys, they may count observations and that sort of thing. Qualitative research focuses on the quality of data in order to understand the data. And so that typically involves things like interviews and maybe ethnographic research where you're observing people in their natural environment. The focus of qualitative research is on developing the richness of data, not necessarily on counting things or summarizing. Now, nomothetic approaches, which are about norms, often use quantitative methods to summarize and generalize larger data, although not all the time. While idiographic approaches often use qualitative methods to understand unique variations in depth, though there are exceptions to that too. So the next thing we want to look at is the difference between the types of observations. So people oftentimes engage in structured, systematic observations in order to get that qualitative richness of understanding human behavior. And so there's 2 different kinds of naturalistic observation. One is watching animals or humans behave in their normal environment without interacting with them in any way. This is called naturalistic observation. And this has several weaknesses, which we're going to talk about. The advantage is that in naturalistic observation, you can get a sense of people's realistic behavior. Because if you try to put them in a laboratory, one of the downsides, which we're going to talk about, that is they might fake their behavior. But when you're watching people in their natural environment, you're getting a real assessment of realistic behavior. The downside, the disadvantage is that there's a lack of control. maybe people may not want to be really participating in it. So that, it's hard to, you have to ensure that there's some ethics about the consent process or the lack of consent. And you can't really know people's minds unless you actually ask them sometimes. So, but it does give us a sense of at least their external behavior and how they appear to others. Laboratory observation, on the other hand, involves watching people or animals in an artificial but controlled environment. And there are advantages to that. You can have complete control of the situation, which allows you to rule out any potential confounding variables, because like in a natural environment, and just to give you an example, a natural observation might be like, let's say I want to go to the cafeteria and watch my fellow students in their natural environment, or I want to watch people in a restaurant as they interact with each other. But the downside is you don't know what other factors are going on that could be potentially influencing things because you're not asking them questions. In a laboratory, you're able to control for potentially external influences that could ruin or bias your results. So you're able to control for those things. On the disadvantage of a laboratory observation, which is where you put people in a controlled situation, like you create a simulation or role play or something like that. The downside is that when people know that they're being watched or observed, they're typically going to act differently because they want to fake good. They want to look good to other people. So they may not act the way they typically would in their given situation. Like, for example, if you're testing a couple and you want to see if they're going to get violent or not. Well, they're not going to do anything bad because they know they're being watched. Another type of, there's another category of research, and a way of dividing these. One is a case study. And a case study is a detailed investigation of one person or situation, often using things like interviews, for example. Another type of case study might involve a psychological test that may be conducted to study a particular individual or a group of people. But I think the most common method of doing case studies is through interviews. I should mention that more emphatically. Then, in contrast to case studies, are surveys. A researcher will ask a large group of people a series of standardized questions about the topic under study in a method called a survey. Now, why would people do surveys? Well, the advantage of that is that we can be able to generalize based on large numbers of information from a large number of people. And so there's different purpose for these kinds of research. Surveys are a type of nomothetic research. The idea is people are trying to make generalizations about what is average and normal response. You're not typically looking for variations or exceptions in surveys, although you might, but it's still going to be summarized as a statistic. In a case study, it's an ethnographic research because the focus is really on that variation. Your focus is more on why do people do different things. And so they might just interview one person to just discover why their behavior is outside the norm. For example, I know people have done research on affairs and infidelity, and they might just interview that one person and publish a whole case study on that. Okay, so there's advantages and disadvantages to both. The advantages to surveys that you can get a large amount of data, and you're able to ask about sensitive topics, and you can make generalizations. The advantages to case studies is you can get tremendous amount of detailed information. You're able to understand the unique variations, and it's useful for generating hypotheses that you can follow up with a survey, for example. The disadvantages to surveys is that most respondents may not always tell the truth or remember information correctly, although that could be said about case study. Although with a case study, you can at least follow up more with more probing and challenging questions if you think someone's lying. Another disadvantage or concern with surveys, you have to be concerned about how a sample is representing a larger population. That's known as sampling. You have to make sure that your sample is not biased or skewed and that truly represents the larger population that you are interested in. So for example, if I'm studying university students and I can't possibly go out and survey everybody because it's going to be too many students. But I might go with a sample. But how I get that sample is going to be tricky because let's say I only ask freshmen. Well, the freshman experience might be different from senior experience. They might have seniors might be more burned out by the end of 4 years. On the other hand, if you focus on residential students, you might miss the experience of commuter students. Or if you only ask students in general ed, you might miss those who have different experiences in their majors and that sort of thing. So you have to look at how you represent it. Also, racial demographics, gender demographics, you have to look at all those things and how they truly represent the larger population. Now, with case studies, the downside of case studies, while you can get rich information, the downside of that is it's not generalizable. While the importance is that you're more focused on the individual variation, the downside is that information cannot be applied to other people because it's only for that one or two people. And sometimes people make the mistake of trying to apply case studies to a lot of people and they forget that's not the point of it. So another method of research is correlational research. And that's the purpose of that is to find relationships between variables. A measure of the relationship between two variables is called a correlation. This allows researchers to discover and predict relationships between variables. And here's an example of a chart that has an x and y axis. And this is an example that shows you how things might correlate. And this is a scatter plot or graph. So on the x-axis, we might have a person's age, so as they get older. And I just threw those numbers together. It's not accurate. But let's say as a person gets older every year, they add another inch or centimeters or whatever. So they get taller as they get older. And this is an example of a positive correlation. A positive correlation exists when increases in one variable are matched by increases in another variable. So, for example, as your study time increases, your grade increases. And vice versa, as your study time decreases, your grade decreases. So here's an example of some scatter plots. On the left is a very strong correlation. It's almost perfect. It's a one-to-one correlation. It is perfect, one-to-one correlation. And this presents a ratio of 1, as I said, 1-to-1. But rarely in social science will you find a perfect correlation. Even the one on the right is a very strong correlation, and you can see it's not a perfect line. And this is a scatter plot because you can see a lot of dots on the graph, but you can overlay a trend line, like the one on the left, where you can see that the line overall is increasing. So overall, things get bigger as the x-axis gets bigger, the y-axis gets bigger. There will always be exceptions, which is normal, but generally you will find this trend to be true. In contrast, a negative correlation exists when increases in one variable are matched by decreases in the other variable. So as x increases, y decreases, or vice versa. As y increases, x decreases, and that sort of thing. So a positive, this is actually the number 48 is wrong, but you can see in the chart an example of a negative correlation. So a negative correlation exists when increases in one variable are matched by decreases in the other variable. So you can see as x gets larger, the y goes down. So negative correlation points down. And some variables have no relationships between them. So in this scatter plot, you can see a big blob, or it's kind of like a circle shape. And that's because there really is no relationship. So if you were to put a trend line on this, it would be basically flat or 0. So the ratio of this would be 0, whereas in a negative correlation, it would be a negative value. So a positive correlation gives you a positive number, which we're going to see. So either way, the downside of these, just so you know, is that correlations cannot be used to prove cause and effect relationships. As we often say, correlation does not equal causation. You can say, yeah, there's definitely a relationship, but the problem with correlations is you can never know if there's another variable that could be potentially influencing both. So correlations cannot truly establish causation. Just to give you an example, my PhD research was on I looked at the imbalance of power in couples, and I wanted to look at how did that relate to marital satisfaction? And I found that the wife's perception of the imbalance of power in the relationship contributed to their dissatisfaction overall for both the husband and wife. So you could say that was a negative correlation. So as her perception of the imbalance increased, then their satisfaction with the relationship decreased. But what I cannot say is that even though I found a relationship, I cannot prove based on that correlation that imbalance causes dissatisfaction, although I can have a theoretical assumption. The reality is that I can't prove that with a correlation alone. I have to use other things. So correlations are usually expressed as an R value, and as I said earlier, positive correlations usually have a positive number between 0 and 1. A 0, the higher the number is, the stronger the relationship. If it's a 0, that's a flat line and basically means that there's no correlation. So anything between a 0 and a 1, which is a decimal or a percentage value, that would be a positive correlation. So let's say you have an R value of 0.5, then it's a variance explained as 50%. A negative number, anything between 0 and -1, would be a negative correlation. So as the ratio is negative. So as your X increases, the Y value decreases. And so that's a negative ratio, negative correlation. And so R values are the way people communicate a correlation. And so we'll be looking at some of that throughout this course. As I said, correlations cannot prove causation. So how do we prove causation? Well, there's only one way we can do that truly. An experiment is the only way we can truly establish causality. This is a deliberate or tightly controlled manipulation of a variable to see if the corresponding changes in behavior result, allowing the determination of cause and effect. So the following are steps in designing an experiment. And we'll talk a lot about experiments as we come across them in this class. The first step is you have to identify what your research question is. So and typically a research question will look like something like, does change in X lead to a change in Y? And those are our independent and dependent variables, which we have to figure out. The independent variable is the one that is changed or manipulated by the experimenter to see if changes will occur. And the dependent variable is the outcome variable. So for example, if we wanted to look at does the type of dogs that someone encounters, does that change whether people are afraid of them or not? So the type of dog would be the independent variable, whereas the dependent variable is the response of fear or not. And because that variable depends on the independent variable. Another example, here's an example. Does a change in music volume affect studying? So in this question, the research question is, does a change in volume affect studying? The independent variable is the variable that is manipulated. So in this case, it would be the music volume. Does changing the music volume, that's the independent variable, how does that affect the studying? And so the dependent variable is your outcome variable because it depends on the independent variable. So in this case, the dependent variable is students' grade on quiz. So we would want to know if we change the music volume, how does that affect the grade on the quiz? That's the dependent variable. So the second thing, once we know what our IV and DV are, then we want to create an experimental or treatment group and a control group. That's because we want to be able to compare two groups. Otherwise, if we didn't have anything to compare against, we wouldn't know if this truly was a change that we would expect based on the variables. So the experimental group is the one that receives the treatment, whereas the control group is the one that receives no treatment or no intervention. And then we use random assignment. This avoids other factors influencing outcomes. So we want to randomly assign people to either the experimental group or control group. If we put all certain kinds of people in one group, like let's say we wanted to study the music volume, but we only put people who enjoyed or they were good students, and they put all the good students in the treatment group, but they put all the bad students in the group that didn't receive music, well, then you might assume that the grades were due to the music when it really was because you put all the good students in one group and not the other. So you have to make sure that both groups are consistently the same. And we do that through random assignment to avoid any potential bias. And the fourth step is we create operational definitions. That's defining it's just creating definitions of how we achieve success. It also means how do we operationalize the variables. Like, for example, in my study on power and marital satisfaction, one of the biggest issues was how do I operationalize power, because it's such a vague concept. So I had to create a scale that would operationalize that. Okay, so there are some important issues when we conduct experiments that could dirty your results that we have to look at. These are experimental hazards. There are at least several confounding variables or factors that could hurt an experiment. The first thing is dissimilar groups that introduce a bias. Then there is the placebo effect, experimenter effect, and we resolve these through single blind and double blind studies. First, comparison groups such as experimental and control groups, as I said earlier, need to have a similar composition and be conducted simultaneously under similar conditions. We want to do it simultaneously to rule out the potential for historical effects as well, like maybe due to the timing of the year or people's life circumstances and changes in the environment. We want to make sure that they receive the same treatment and conditions. Otherwise, it's difficult to know if the outcomes are not due to other factors, such as differences in the kind of people in the groups or outside environmental conditions. Experiments often use random assignments to ensure that the comparison groups are generally equivalent and that bias does not skew the results. A placebo effect is when people change simply because they believe something will affect them, regardless of the actual potency of the intervention, rather than being a direct result of the intervention. So, for example, let's say you did a research study on the effects of a medication. People might get better just because they think the medication works, even if it didn't. But because of hope and the expectancy, they might just get better on their own. Or let's say you did a research study on the music volume and quiz scores, and maybe they believed somehow because you led them on to think that music would actually help them improve, they might actually get better because of the idea that they're going to do better. So we have to look at how we would rule that out. The tendency of the experimenter's expectations for a study to unintentionally influence the results of the study is called the experimenter effect. So, for example, let's say I have hope for some people, like in the music example. Let's say I expect that one group is going to succeed and be superior than the other group, then I might be more biased in how I treat them. I might be more encouraging. I might grade things differently or so forth. So there are ways we can get around that though. So there's two ways we can control for these kinds of effects. A single blind experiment is when subjects do not know which group they are in. So maybe they both receive a pill, for example, in medicine. They might receive a pill, and one of those pills is a placebo, meaning it's a sugar pill. In psychology, that might be you don't know what kind of intervention you're getting, and they may not tell you what kind of intervention you're going to get, because otherwise you might be biased into thinking you should be more effective or not. A double-blind experiment is when subjects do not know what group they are in, and neither does the experimenter. The experimenter does not know. So it's a blind experiment. And so the experimenter codes things so that they're not biased towards a certain direction. And so that brings us to the ethics of psychological research. When groups of psychologists or other professionals who look over each proposed research study and judge it according to the safety and consideration for the participants in the study, they are interested in the ethics of the study. In the United States, to protect human subjects, an institutional review board, IRB, is usually required to review the research beforehand. So I had to have all my research approved by an IRB. And so there are certain guidelines for protecting humans in research. We have to protect their rights and their well-being. We have to make sure that they give informed consent. That means giving participants enough information to decide. And if you withhold information because you may think that you need to in order for the experiment to be successful, if you do that, then you have to justify when that deception is going to be used. And so that justification also goes through the review board. Then the right of participants to withdraw at any time must be given. Participants must be protected as much as possible from risks, and they're debriefed at the conclusion of the study. Their confidentiality must be maintained, and if there's any ill effects, like someone got traumatized or evoked negative emotions, that there must be some kind of remediation available for them. Animals in psychological research make useful models because they're easier to control than humans. So we don't want to inflict harm on humans, so we never want to inflict harm on humans. So unfortunately, sometimes animals may be involved, but and the reality is that they have simpler behavior and they can be studied in ways that are not permissible with humans. However, even animals need to be protected, and so therefore the advantages of research on animals must be weighed against the disadvantages. And so that's why it also needs to go through a review board. After all this, there's only so much science can tell us, and there's certain limits to science. There are some things that science cannot tell us. For example, science can only make observations about the world as it is. It cannot tell us why things are the way they are, nor can it tell us how things ought to be. We're going to talk about the is and ought fallacy coming up. Therefore, science cannot offer truth and morality and ethics. I mean, you can survey people and get an idea, but still, you cannot establish whether that majority opinion is correct or not. And another example is you cannot use science to prove, for example, that the Nazis were evil because you're basing it on some moral standard or social standard. But as we saw in the past, societies and cultures can be wrong. Like, for example, the Nazi Germany, when they killed people, many people there would have said, hey, I was doing what everybody else is doing. Well, okay, but that's not good either. And so this picture is from the Nuremberg trials. So science can only take us so far. At some point, there is a sense, philosophy comes in, there's a sense of morality and ethics that also come in. Though psychology is often interested in how people perceive beauty, science cannot offer truths about what is beautiful. And that's another limitation. Again, it can tell us what people often think, like it tells us about symmetry and there's principles of beauty, but we don't know if that is an objective truth. It isn't really an objective truth. It's a subjective opinion based on majority opinion. Okay, so there are some fallacies in thinking. We talked about critical thinking. What are some fallacies in thinking? A logical fallacy is an error in reasoning. Some people commit these when they confuse is and ought. For example, just because something is that way, like murder, doesn't mean that it ought to be that way. And this principle comes from David Hume. He's the one who taught this distinction. And there's specific fallacies related to this. A naturalistic fallacy is when someone reasons from is to ought, suggesting that because people are a certain way, they ought to be treated a certain way. For example, men and women score differently on tests, therefore they should attend different schools. Well, no, just because they attend that way, just because it is that way, doesn't mean it ought to be that way, or it doesn't mean they ought to be treated that way. Another example is just because people of color score lower on an IQ test, therefore they ought to be in separate educational system or treated inferior because of their race. And that was a logic that was used. But again, people forget, well, just because it is that way doesn't mean it ought to be that way. Maybe there's a reason why that IQ test is scoring differently, and maybe that needs to be changed as well. Another example might be extramarital sex is common, therefore everyone ought to do it. Again, just because everyone's doing it doesn't mean it ought to be that way. A moralistic fallacy is when someone reasons from ought to is. For example, because people ought to be treated equally, everyone is genetically the same. Well, that's not true necessarily. Men and women ought to be equal. Therefore, women are just as strong as men and men are just as empathetic as women. Well, maybe ideally, but there may be many exceptions to that. And there may be differences in averages. And we don't want to overlook differences just because it ought to be that way. Certainly they should be treated the same way. But overlooking differences may overlook ways people are treated differently, like pay. For example, certainly men and women should be paid the same, but they are not, and so we want to be attentive to those differences. And here's another example, because good people ought to not get angry, your anger does not exist, or you should repress it. That's something I used to think. I used to think you shouldn't get angry, therefore I would try to repress it. Well, the antidote is to accepting it. It is what it is. Another example, good people ought to be strong, therefore I am strong. Well, sometimes we're not, and that's okay to recognize it is what it is. And last one, here's an example from the Bible. The Bible describes the earth as having corners, therefore the earth is flat. Well, just because it says that thing doesn't mean that's how it ought to be. Sometimes what is doesn't mean it ought to. Maybe it should have said something differently. We want to be open-minded about that. So people are committed to a certain ideology, whether a liberal or religious ideology, tend to commit a moralistic fallacy. They tend to overlook reality. This is important because some people do not want to accept scientific research because of the potential implications for their ideological beliefs, such as when Galileo was persecuted by the church for challenging the belief that the earth was the center of the universe. In addition, some people are more progressive in their ideology, may fail to recognize times when reality does not match their ideology, no matter how good that ideology may be. For example, a belief in the equality of men and women should not cause us to ignore times when men and women are different, for whatever reason. And we want to be aware of those. We don't want to ignore it and be too naive and idealistic. In conclusion, or the last section, I just want to say that truth may be subjective sometimes rather than objective, and we have to be open-minded about that. As mentioned before, science has limits. We talked about beauty and things like that. Even science contains a priori assumptions. For example, science assumes that there is an external objective reality that is knowable and that we can gain and understand of the world around us. The laws of nature or physics are consistent and act the same in different places. Well, that is an assumption because we don't know that there may be times when the laws of physics don't apply. We can only know what we can see. And we must not, in other assumptions, we must not use God as an explanation for why things occur. That is a scientific assumption, but maybe we can't prove, or we will never know if God is at work if we only use science, because it's not testable using science. And so there has to be the open-mindedness about other sources of truth. Our background experiences and our personal story informs how we perceive sensory data and informs our understanding of objective truth. We may not even be as objective as we think we are. That's why a lot of times people who engage in research, as objective as they think they are, they may be biased. That's why they have to look at the funding sources, because sometimes research that's funded by a group might promote certain research that supports their agenda. So we always have to be careful that we're not as objective as we might think we are. In postmodern times, there is an emphasis now on how our experiences are subjective. For example, people believe that you cannot dispute one's own experience. And there may be an element of truth in that. I personally use a phenomenological approach, and that basically means that phenomenology is the psychological study of subjective experiences. Subjective experiences correspond to an objective reality that exists independent of our awareness. Postmodern psychotherapy often tries to work within the client's own understanding of truth and their own subjective experiences rather than prescribing what they ought to believe. So in the past, doctors and even psychoanalysts, They would approach the client as the doctor or the expert. But in these days, counselors and therapists oftentimes do not try to come at a client as an expert because the client wouldn't like it. We try to come at it more as a dialogue and seeking to understand the client's experience and their understanding of truth rather than us imposing what we believe is the truth on them. So that brings us to our closing.
So as we said, thinking like a scientist actually requires a lot of humility. Imagine what it would be like if you were in a relationship with somebody, like we talked about earlier, where the person didn't ask questions. What would it be like? It's not a good feeling because people make assumptions. They assume a lot of things about you, and that's not very positive. So it takes humility, and it also takes open-mindedness. Otherwise, imagine when we make assumptions, that's what leads us to be bigoted and closed-minded. So when we're open-minded, that's a good thing. Okay. When we face challenges, one of the things we can do is science it. That basically means we stop, ask questions, and listen, and then that allows us to think about solutions to the problems. And that's what we do with psychology. We do research so we can figure out how to solve problems.
I have a confession to make. I love atheists. Why? Not only because they are fellow travelers in this journey of life, but also because of their love of science, their critical thinking, and their skepticism that demands empirical evidence. A lot of people do not realize that psychology and the mental health professions are also scientific disciplines, so it's only natural that we have something in common. Contrary to popular perception, science also appears in the Bible, though different words may be used.
Let's talk about wisdom and the importance of wisdom in science. Wisdom was important in ancient times. In fact, in the Bible, King Solomon was known as the most wisest person of all times. And he was also the king of Israel and was very wealthy and famous. But if he had one thing he wanted to choose, it would be wisdom. In fact, he says this in his book of Proverbs. He says, "Wisdom is more precious than rubies. Nothing you desire can compare to her." This is in Proverbs 3:15. He also personified divine wisdom as a woman. He says, "Don't turn your back on wisdom, for she will protect you. Love her, and she will guard you." The ancient Greeks also had a reputation for their love of philosophy. They had famous philosophers like Aristotle and Plato and Socrates. And the word they used for being an expert in something was sophist. And the word for wisdom they had was Sophia. And it's interesting, when the Greeks translated Solomon's Proverbs into Greek, they used the word Sophia, that you might recognize, to translate the word wisdom into their language. And wisdom to the Greeks meant an understanding of things, and it meant intelligence and judgment and discernment. So it's interesting that the wisdom that Solomon was talking about, he was talking about spiritual wisdom, but it also was connected to intelligence and reasoning and discernment. So there seems to be a connection between our spiritual ability to discern and the Holy Spirit. Solomon also understood something about wisdom that few people today really understand. For him, wisdom was more than just an accumulation of knowledge. It was about understanding our responsibility to the world. It was about our sense of morality and values and ethics. In fact, he says in chapter 9, verse 10, "The fear of the Lord is the beginning of wisdom." And then he also says that humility is the fear of the Lord. So genuine wisdom is not about just knowing everything. In fact, you can know a lot of stuff, but not really be wise, actually. And that's probably why he ends his book sounding a lot like a social justice warrior. He says at the end, "Speak up for those who cannot speak for themselves, for the rights of all who are destitute. Speak up and judge fairly, defend the rights of the poor and needy." That's in chapter 31, 8 and 9. So many people in the ancient times understood that morality and virtue were the most important subjects when it came to philosophy. And so many people became experts in moral law and ethics. And yet, while they became such experts in these things, they also tended to forget the point of why they did what they did. And so Socrates, who went around and investigated these, or just trying to understand if these people were really wise, really felt like they didn't really measure up to their own standards. That's why, in the end, he really came down to an understanding that wisdom also starts with a recognition of our need, a recognition of our limits of understanding. We don't know everything. We don't always get it right. Solomon recognized that true wisdom starts with an understanding of our ignorance. And in the same way, we have to, as Christians and believers, we also believe that real wisdom recognizes our dependence on God, who truly knows everything more than we do. And that's why Paul writes, I count all, and remember, Paul was he was the most knowledgeable person of his time, one of the most knowledgeable people of his time. He's highly educated. Of all people, he could claim to know a lot of things. And yet, he said he counted all that as garbage compared to the infinite value of knowing Jesus. And he says, knowledge puffs up, but love builds up. The one who thinks he knows something does not yet know anything. That's 1 Corinthians 8:2. Another reason why I love atheists is because they're at least honest about their beliefs. I'd much rather somebody who is very honest that they don't believe in God than somebody who says they believe in God but does not live like it and does not act according to it. We probably all know lots of people who are so-called Christians and yet are anything or act like anything but. And they have hateful attitudes toward people and that sort of thing. And that's why, Paul wrote a lot about that in his writings. And just as Socrates went around and pointed out the hypocrisy of the so-called sophists, the people who were experts at the time, Paul also wrote in his letters to the Romans, for example, that you teachers of the law, do you follow the law? Do you keep the law? And he asked the same question. In other words, do people live up to the standards that they say they do? And that's what's called hypocritical thinking. The word hypocrisy has the same root word for critic. And critic is someone who can discern and judge. Ideally, someone who's got a good sense of wisdom. They have the ability to discern what's beautiful and moral. But a hypocrite is someone who thinks they know everything, but they do not live according to standards. They do not act in a consistent way in their life. And by their knowledge, they judge themselves. And so, at least, if anything, a recognition of what we don't know and having humility about our ignorance and understanding our need and dependence on God is going to probably go a long way to improving ourselves, making ourselves better people, because at least we know our limitations. Psychological research by Adam Galinsky and colleagues in 2005 and 2009 found that the more power people have, the more likely they engage in moral hypocrisy. Why is that? Why is it the more power you have, the more hypocritical you are? So in their experiments, they found that powerful people were stricter in their judgments of other people than on themselves. That's pretty hypocritical, right? And we can probably think of a lot of politicians, for example, who put themselves on pedestals and they think they're the greatest, and yet everybody else can see the hypocrisy of their own standards. So it was theorized that the hypocrisy enabled them to maintain their power, in their own mind at least. As a therapist, I've discovered that if I really want to be effective with people, then rather than approaching people like I know everything, that's not going to win people over. I think I've had a lot more success when I recognize that, I don't know everything, especially when I became a parent. I used to think, I can handle this parenting thing. I can, be a therapist and help people with their parenting. But when I became a parent, I realized, man, I might have a PhD, but I don't feel like I know anything. But you know what? When I meet parents, it actually helps me be a lot more empathetic, because now I understand a little more about what it feels like to feel like you don't know anything. And people are much more They appreciate that because they would rather go to somebody who understands their limits than to go to somebody who thinks they know everything. And so a recognition of our limits allows us also to be more authentic and to be empathetic and caring of others. Otherwise, when we think we know everything, it's condescending and puts other people away. So critical thinking and logical reasoning are very important also for the sciences. Like we said, we have to have a humility and an open-mindedness. And Plato, who was a student of Socrates, believed that ideas existed in the mind. He was a nativist, as you recall. And that nativist idea may have influenced the New Testament. In the New Testament, the Greeks believed in this idea of the Logos. The Logos was this rational principle that ordered the universe. But when John wrote his gospel, John 1, he said that in the beginning was the Word, and the Word was God, and the Word was with God. That Word is the same Logos that the Greeks believed in, that was a rational force. And so in the same way, we can believe that the universe is understandable because it's ordered and controlled by someone who created it. So if John said that this rational force, Logos, was God, then it only makes sense that through reasoning, we can come to understand God. And Plato's student Aristotle also developed a system of logic that was based on this idea that the mind had innate ideas that simply needed to be uncovered or exposed to reasoning. And God is also a God of logical reasoning. Using our reasoning helps us to understand the world, which can help us to understand God. In the same way, Ellen White writes in the book Education, she says, nature testifies of God. The same power that upholds nature is working also in man. The same great laws that guide, alike the star and the atom, control human life. So when we understand the world around us, it helps to understand God because nature testifies of God. And also, God invites us in Isaiah 1:18. He says, come, let us reason together. He's a God of reason. He wants us to reason with him. So that rational force, the Word, invites us into a dialogue with him. Going back to the atheist thing, I think that even Jesus loved atheists. Doubting Thomas, remember the Apostle Thomas, he might be considered one of the atheist disciples because he said after Jesus died and was resurrected, he said, unless I see the nail marks in his hands and put my finger where the nails were and put his hand into his side, I will not believe. Thomas could be called an empiricist. An empiricist simply means that we believe things through our senses, a sensory experience. Now, while science is also based on empirical observations, but while science is based on empirical observations, there is a limit. There's only so far we can go with that because there's some things we would just never be able to prove with empirical evidence. Like how did the world begin? How did the universe begin? There wouldn't be any empirical evidence before the empirical evidence began. So at some point you can't prove the start of the universe. That's not something we can discover. It's because God exists outside of time and space. So there's no way we can actually discover God through empirical evidence. However, and that's what the Bible says, but Ellen White also says something to this effect. She quotes Deuteronomy 29:29. She says, the secret things belong unto the Lord our God, but those things which are revealed belong unto us and to our children forever. Just how God accomplished the work of creation, he has never revealed to man. We'll never know. Human science cannot search out the secrets of the Most High. His creative power is as incomprehensible as his existence. This is from Patriarchs and Prophets. Another thing is science cannot define what beauty is for us. It cannot define morality. There's just some things we cannot prove without some authority or some spiritual guidance because those are the limits of what science cannot do. Science cannot teach us the principles to live by. And only our faith gives us courage to live by some moral principles. Ellen White says this, what other book will teach men to love, fear, and obey God as does the Bible? What other book presents to students more ennobling science and more wonderful history? That's Fundamentals of Christian Education. Some believe that scientific research is opposed to God, but I don't think so. I think science is reconcilable with God. She says, God is the author of science. Scientific research opens to the mind of vast fields of thought and information, enabling us to see God in his created works. God is the foundation of everything. All true science is in harmony with his works. Science opens new wonders to our view. She soars high and explores new depths, but she brings nothing from her research that conflicts with divine revelation. Now, let me ask you something. Did Jesus shame Thomas? Did he reject him because Thomas said he wanted some evidence? No. Did he turn his back on him? No. In fact, when Jesus was raised from the dead, he walked directly to Thomas and simply invited him to empirically test it with his own personal senses. He says, put your finger here, see my hand, reach out your hand and put it into my side. Stop doubting and believe. How did Thomas respond? He immediately became a theist. He said, my Lord and my God. You know, of course Jesus did say, happy are those who have not yet seen and believe. And that is what faith says. In fact, the writers in Hebrews 11 says, faith is the evidence of things, of what we hope for and certain of what we do not see. We may never have all our questions answered, but ultimate peace and happiness comes through a complete surrender and trust from God. But skepticism is no obstacle to God. It's just a different path there. Ignorance, Ellen White says, ignorance may try to support skepticism by appealing to science, but instead of upholding skepticism, true science contributes fresh evidences of the wisdom and power of God. Rightly understood, science and the written word agree. Rightly understood, okay? And each sheds light on the other. Together they lead us to God by teaching us something of the wise and beneficent laws through which he works. That's counsels to parents, teachers, and students. And look at what Thomas did. Thomas tested Jesus, and he became one of the most faithful disciples, that he even went out as a missionary and died for him. Some of the most powerful Christians in the world today were former atheists who decided to put God to the test. For example, I think of Lee Strobel, who was an atheist, an investigative journal for the Chicago Tribune. And he set out to objectively disprove his wife's Christian faith. And so he decided to investigate the evidences of Jesus, and in the process became a Christian and wrote the book, The Case for Christ. I honestly believe that many atheists are on a similar spiritual journey. It may look different, but they're just looking for evidence to live by, and I think that's fair. Rather than treating them as outsiders, I would rather treat them as fellow travelers on the road. But you know, here's the good news. I think God invites us all to put him to the test. Some people think, well, that God says, do not put the Lord God to the test, right? In Deuteronomy it says that. But the context is simply suggesting that we don't act in outright disobedience and then trust God, expect God to save us. And on another place, though, God actually does invite us. He says, put God to the test and see how kind he is. See for yourself the way his mercies shower down on all who trust him. For Psalms 34:8. And elsewhere he says, bring the whole tithe into the storehouse so that there may be food in my house, and test me now in this, says the Lord of hosts. If I will not now open for you the windows of heaven and pour out for you a blessing until it overflows. You know, I really think that God invites us all to test him. And this may be the most important experiment we can ever conduct in our lives. And Ellen White's finished with this. This is what Ellen White says. While the knowledge of science is power, the knowledge of Jesus, that Jesus came in person to impart, is still greater power. The science of salvation is the most important science to be learned in the preparatory school of earth. The wisdom of Solomon is desirable, but the wisdom of Christ is far more desirable and more essential. We cannot reach Christ through mere intellectual training, but through him we can reach the highest round of the ladder of intellectual greatness. While the pursuit of knowledge in art and literature and in trade should not be discouraged, the student should first secure an experimental knowledge of God and his will. I'd like to invite each of you to test God and see his mercies and greatness, as he says. He invites us to. And that is my prayer for each of my students. true wisdom is recognizing we don't know everything in this world. We can't prove everything empirically. There's some things we'll never know. But we can, with faith, we can recognize that we don't know everything and look for something for us to depend on. Something that gives us moral guidance in this world. Something that gives us hope and courage. And that's my prayer for each of you. Thank you for joining me, and I look forward to having you join me in my next chapter on chapter 5, Just Pray About It, where we're going to talk about the integration of faith and science.